have a look at the effect of inflation and what even is inflation. So it's the name given to the process in which goods and services increase in cost over time. But what does that mean in real terms? Here's a canteen prices from 1978. So maybe your parents or grandparents were at school in this time, and this is how much it would have cost them at the canteen. Have a look at something that you might be familiar with on that list, maybe like a pie or a sausage roll there. How much did they cost? What have we got here? 35 cents for a pie and 23 cents for a sausage roll there. Cheap by today's money. And so the idea of inflation is that these costs increase over time. And so the buying power of their money reduces. So think, if they went to school back then with 50 cents, thinking about what they could buy for their lunch, 50 cents. In 2023, if they had 50 cents, could they buy a pie and something else? Absolutely not. So the buying power of the money reduces over time because prices inflate. So we need to work out what's the equivalent then of the 50 cents now as opposed to back then to have that same buying power. And so your money too, if you invest it into a savings account of some sort, yes, you're getting an interest rate, but you want to work out what's called the real rate of return to see if the buying power has stayed the same. So to understand the success of your investment, this inflation needs to be taken into account for this real rate of return. Here's a little scenario to consider, what's good and what's bad. So if the real rate of return is 0, then that means you haven't increased your money over time, but it's still maintained the same buying power. If you get a negative number, that's not good. It means that $5 that you say could take to the canteen for lunch, in 10 years' time, does now not get you the same amount of stuff. But if the percentage gain on your investment has increased, that's good. That means you've got more buying power than what you started with. So let's do 2 examples to work through that. How do we do that? What's the process involved? So first of all, we have to determine what is the future value for our investment. So you've invested it, looking at the percentage interest rate that you get and using our graphics calculators for that. And then working out the index value of the principal. So that's the way we do that is this formula here. So we're going to take the principal number, multiply it by the rate and to the power of the number of years. So hence the word indexed, index laws, that sort of thing. In each of these questions, you will be given the rate of inflation to take into account there. And then this new number that you've got will become the principal at the next step. This might sound a bit confusing at the moment, but as we get into the process, it'll make a bit more sense. And then to work out the real rate of return, we've got 2 dollar amounts that we're trying to compare. We've got the future value that your investment, your savings account has actually become. But then the index value of the principal is what it should have become so that we can compare them and see if there's a positive or a negative difference between them to see if it's been a good investment or not. Just some notes when we get to this step of the process, noticing that the PY and the CY are 1, and in N it's going to be 1 multiplied by the number of years because we're just looking at as though that's been indexed once a year, and then we've got $2 amounts that we're working with and that we'll be solving for I. Let's put that into practice. So Mandy invests $10,000 in a term deposit for 3 years at 5.4% PA per annum per year, compounding monthly. So if inflation averages 2.5% per year, which is about standard, over the 3-year period, find the real rate of return and comment. So first of all, let's put these numbers in just like we would normally with a compound interest question. So for the $10,000, let's do that. So Mandy invests it, it's going away from her, so that's our principal amount, and it's a negative because it's going away from her, negative $10,000. For 3 years, so that's part of our N, but the compounded monthly part we put in first. So N is how often multiplied by how many years, 3, remembering that 12 goes down here for the PY and the CY too as well. What else have we got there? The 5.4%, that's our interest rate. 5.4, payments are 0, which means we're solving for our future value, which comes out to be $11,754.33. So that's how much her deposit has earned, and that's what it's become. That $10,000 is now in the $11,000 amount. Now let's work out this indexed value. So there's the formula we've got there. Let's work that out. So the principal amount's what we started with, that $10,000 amount multiplied by bracket 1 plus the rate. Maybe I'll just do this off to the side. So 1 plus the rate, which is the 2.5%. So when it says rate there, that's not the 5.4, that's the indexed amount. So we're adding that on, that's 2.5%. Now remembering that 2.5% is equal to, we put that over 100, so we'd get 0.025. So essentially we've got 1 plus 0.025, and that's what we're going to have here, 1.025 when you add those two together, to the power of the number of years. So we've got 3 years here, and that is equal to $10,768.91. That's becoming our PV in the next step. Just a note too, that the other way of working this out, I suppose, if you wanted to, is that it's $10,000 times by the inflation rate each year. So it's a multiplier, if you like, when we're indexing something. So we're timesing that for 1 year at 2.5%, timesing it by another year at 2.5%, and then another year at 2.5%. But if you remember your index laws, when they're the same base and they're being multiplied together, you add the powers, and hence why we've got it to the power of 3. So that's what's happening in that formula. So this is our new principal amount that she's earned. So we're going to use that in the next step. So to get the real rate of return, this is step 3 in the process, we need to take that principal value. So let's put that in here. Now that money is going away from her, so we're making that a negative number, which was $10,768.91. What else can we fill out? The future value was what we calculated when we did this table the first time round. So the actual future amount here is this, the $11,754.33. Now this is where it's unique. The PY and the CY, we're making 1, and technically n is 1 multiplied by the number of years, but you could really just keep that as the number of years, 3 there. Payments are 0, and we're solving for I. So in your calculators, that comes out to be 2.96%. Positive or negative number there? Positive, that's good, right? So what does that mean? That real rate of return is a positive number, 2.96%. So the investment has gained buying power and it's been a success. So that's what you're looking for. That's what you want. Let's do an example where it doesn't work out to be. So you can already have noticed the difference. If your future value is greater than what the indexed value is, then it's going to be a positive number. But if it's lower, that's not good. So Scott, he invests $15,000 in a term deposit for 5 years at 3.2% per annum, compounding quarterly. If inflation averages for this time round 3.5% per annum per year over the 5-year period, find the real rate of return and comment. So let's work through this one number at a time. He invests $15,000. Where should we put that? Put it in our principal value amount as a negative because it's going away from him. Payments are 0. For 5 years, he does that, so that's up at our N, but how often is it compounded? Quarterly. So that quarterly, how many times a year? 4. So that's at the PY and the CY, and also here is our N. It's 4 times the number of years. 4 times 5 is 20 for N. What else do we know? The interest rate, 3.2%. So it's the rate of return there, not the inflation number. We don't need that percentage sign, obviously. And we're solving for the future value, which comes out to be $17,591.46. So his $15,000 has turned into that. But what does it need to, what is it with the inflation? What is his $15,000 when we take that into account? So this index value. So the PV was the $15,000, and we're multiplying that by 1 plus the rate. So it's 3.5%. As a decimal is 0.035. Adding that on to 1, we get 1.035 to the power of the number of years, which was 5. And this works out to be $17,815.29. This is our new principal value. Can you already see what's happening though? when we take into account inflation, his $15,000 is really only worth this much. And well, this is what it should be worth, whereas this is what he's got. There's a difference there. Let's put these into the second step here. Our new principal value, as we said, is here, and this is the negative 17,815.29. The future value is what he actually got, is 17,591.46. PY and CY are 1. N is just the number of years, or it's 1 times 5 if you like. Payments are 0. What are we solving for? I there, and that comes out to be, a negative 0.25%. So that's not good. So what we can say there is, sorry that I wrote over the top there. Here, I'll just write that off to the side, 0.25. The real rate is negative 0.25%, or that negative should be there as well. So the investment has lost buying power and has therefore not been a success. Really take note of the wording here, because sometimes when you do these questions, it's not just about solving for the number, it's about commenting. So writing down these phrases, lost buying power as opposed to gained buying power, been a success or not. So they're really important when you come to answer these questions. Okay, they're the questions to do. Thanks for joining me.